Hello everyone, how is it going so far? We had great talks and a lot more to come, but welcome to my talk. My name is Facundo Giuliani. I'm a software engineer from Buenos Aires, Argentina. I work as a lead web developer at Multitracks.com. Multitracks is a company based in the United States. I'm an Auth0 ambassador. Auth0 is a platform for identity, authentication, and authorization. I'm a Git-Kraken ambassador. Git-Kraken is a graphic user interface for Git. And I'm a Cloudinary media developer expert. Cloudinary is a platform to manage image and video in our web pages. I will mention these products during the talk, but it is not fully related to them. If you want to talk about these products or about any other topic, you can reach me at my webpage, fjuliani.com, at my Twitter account, Facundo Zurdo, or my GitHub page, fjuliani. The name of this talk is Jamstack, Static Sites, and Azure. To talk about that, we will travel in time. We will go to a long time ago in a galaxy far, far away. This will be the only reference that I will make to Star Wars. But going to the 90s, we had this British scientist called Tim Berners-Lee that, working in Switzerland, he created a way of sharing documents through a network, and he created what we call nowadays web pages. The web pages at that moment were documents with static black text and hyperlinks to other documents. Which is funny is that you can go to the URL that is at the bottom of the slide and you can see the web page live. It is alive. And well, the human being never gets enough, and we always want more and more. And the text as it is now was not enough, and we wanted to add format, we wanted to add style to our text. And that's where the web developers or programmers at that moment created CSS. CSS is a way to add color to our documents, different fonts, different text style, images. But after that, what the users wanted was interaction, was dynamic content, was movement in their pages. What they really wanted is to create pages like Homer Simpson's web page with things going from one side to the other. And to do that, in the 90s, they created JavaScript. With JavaScript, we were able to create pages with interactions depending on the user's actions. I mean, if the user did something, we were displaying a different result. Or we were displaying things with movement. Like, you can see an example of this. If you go to spacejam.com, you will see the Space Jam movie, the movie from the 90s. The page is still alive, so you can see it working. And that's an example of the kind of web pages that we created in the 90s. But nowadays, we call those kind of pages static web pages. Why? Because they are web pages that are delivered to the user browser exactly as they are stored in the server. So we have a web server that stores HTML files, CSS files, JavaScript files, and we deliver these files to the users as they are stored without any kind of dynamic content or generating anything on the fly. We deliver the files as they are stored. These other type of pages with dynamic content inside are called dynamic web pages, where some of the content is generated dynamically when needed. So, for instance, we have a user with the browser. He makes an HTTP request to a web server. In the web server, we have static resources, images, CSS files, HTML files, and we use these static resources with other dynamic resources, which are the results of operations in applications or information stored in databases. And we mix them and generate a new HTML document that we delivered to the user again. So what the browser or the user is receiving is a whole new HTML document generated on the fly by the web server. To create this kind of web pages, we have some programming languages available. Many of them still exist nowadays. Java, Python, PHP, or Microsoft ASP. Nowadays we use ASP.NET. But with these languages, what we did is to create applications that enable us to generate HTML documents on the fly in a web server. For instance, eBay portal. If I wanted to purchase something or to browse between products and services, I wanted the experience to be customized for myself. I mean, what I wanted to see is not the same as what other users wanted to see when visit eBay. This kind of generation of pages is called server-side rendering because the HTML content is generated by the web server. And why we mention this? Because with the years, some techniques and some technologies were developed, and a group of techniques and technologies appear called Ajax that enable us to execute JavaScript code and make requests to the web server to generate dynamic content on the fly, but without reloading the complete page, generating dynamic content using JavaScript. So through JavaScript, we call to the web server, we make an HTTP request, and we have new HTML content inside the document that we load at first when we visit the page. And this enabled some tools and frameworks related to JavaScript to be developed. JavaScript evolved, we had more features, and we had more ways to generate content or operations. That's the case, for instance, of jQuery or Ember or Backbone. We were able to create rich interactions and experiences for the user, generating dynamic content with JavaScript. And with these tools and ways of generating HTML content, there were some frameworks that went ahead and they thought, what if instead of whenever I need HTML content for a page, calling the web server to generate a brand new HTML document? And what if instead of doing that, we create an origin or an initial HTML document with JavaScript code inside of it, and all the dynamic content that we want to generate based on the interactions of the user is done by JavaScript calling the web server. And that's the approach that Angular, React, or Vue follow, generating the content using JavaScript. And this whole idea is called single page application. It is a web application that interacts with the user by dynamically rewriting the current web page with new data from the server. We don't leave the page where we are, we rewrite the content of it using JavaScript. I want to stop at the beginning of the definition because we are talking now about web applications. We don't talk about websites anymore because the pages that we are creating were similar to the desktop application that we had at that moment with the operations that we had available to do, or with interactions, the data that was stored, the complexity of them. The web pages were not anymore like the Space Jam website, for instance. We had behavior, and we have behavior nowadays, and that's why we still call them web applications. And this single page application was made, or they are created, following the principle of client-side rendering, where the HTML content is rendered directly in the browser using JavaScript, comparing to server-side rendering, where we generate the HTML content in the server and we deliver the complete HTML document to the browser. And now that we mentioned these types of rendering a page, we can evaluate the pros and cons of them. For instance, the client-side rendering, some of the cons that we have are that we will have richer interactions because as we are not leaving the page, JavaScript will offer a better interface or a better visual and user experience, generating the dynamic content when needed. We will have a faster rendering of the pages after the initial page load. So this means that when we load the HTML file, the initial HTML page, the CSS files, and we execute all the JavaScript code that we need, we will have a web application working, and the rendering of the dynamic content that we need in the future will be faster because we don't have to reload the complete page. The same for the server. I mean, we will have a lower server load because the HTML content is generated in the browser, in the client, and not in the web server. And as we are not reloading or refreshing the complete page, we will have reusable UI components that we can use to generate parts of the page or partial pages inside our initial page. The cons of client-side rendering are that we will have a slower initial page load. I mentioned the page load before, but the thing is we have to wait until all the HTML code, the CSS file, and the JavaScript code is loaded to start using our web application. And I want to stop here because if you are using a framework like React or Angular, you will have to wait until all the initial processing and loading of JavaScript code is ready to display your web application and to start using it. Your web application won't be complete until all the JavaScript code is ready. Another concept that I didn't mention is SEO, which means search engine optimization. And that is a group of techniques and technologies that we can use to create our pages and to make them more discoverable for the search engines like Bing or Google. So they are offered as better results when the users are searching for pages. So in the pages, we add some tags or we order the content in a certain way to make Google and Bing robots an easier work when analyzing our websites. These robots analyze the tags, the HTML tags that conform our pages, and the content and how it's organized. And depending on that, they make an evaluation of our page and make them more discoverable for the users. The problem with client-side rendering is that most of the code, the HTML content that we will display in our pages is generated dynamically with JavaScript. So comparing to server-side rendering, if the robot requests the page to the server and he gets a complete HTML page, he will get a better evaluation of the page than requesting a page and having to wait for JavaScript to execute and to generate the content. Nowadays, the robots understand JavaScript and can analyze JavaScript, but is not as performant as the server-side generated pages. And lastly, we will have a lot of dependencies on external libraries. If we create a page using React or Angular, we will depend on them for our site to work, or other libraries or frameworks that we use. About the server-side rendering, some pros, for instance, we will have a faster initial page load because we don't have to wait for JavaScript to display our page and to start using it. We will have a better SEO because, as we said, we are delivering an HTML page that is ready to be seen and used. Our sites and applications will be more secure because we will have more server-side code, which means that the code is in the web server and it's not visible by the user or display in the browser. That's something that happened with JavaScript. When we create applications with code written in JavaScript, the code is visible for anyone that inspects our document. And we will have a lower user device load because the HTML content will be generated in the server and not in the browser or our computer or mobile phones. The cons of server-side rendering are that we will have busier web servers, and they will be waiting and executing all the requests of pages made by the users. Our servers will have to process all the requests, and maybe we will have an overall slow page rendering because we will have maybe many requests at the same time, and we won't be able to process all of them in a good way. On the other hand, something that we already knew is that we will have full page reload after root changes. Whenever we change the root or we click on a link, we will have to reload the full page. And even though that we can start using the page without waiting for JavaScript, the page will be viewable, but it's not interactive. So that's a decision that we need to make. If we want to wait until we load all the JavaScript code to display our web application, or if we want to display our web application and having to wait for the JavaScript files to properly work and use it. But there was this group of people that started to think, and they went one step forward or backward, and they started to think, do you remember the 90s and the static pages that we had and the benefits that static pages offered to us? So they wanted to create performance sites and beautiful sites like the Space Jam website or this other beautiful web page that we saw before, but offering dynamic content to the users. So they started to think about the benefits of the static web pages, and they saw that the static pages are fast because they are files delivered by the web servers without any dynamic processing or on-the-fly HTML generation. They are cheap because we don't have any platform to be configured and maintained to deliver static assets and static files. They are easy to maintain because we can even drop the files in the web server manually, and they will be available for us to browse them and to use them in our website. They are more secure because we don't have any code executing when we visit our websites. And well, there's this phrase that says that there's no code more secure than no code. So if we don't execute code, it's more secure than executing any kind of code. So as we are delivering files as they are, that will be more secure, and that will be easier to scale because the only thing that we need to do to increase or to make our page, our site bigger, is to add more storage. And they are stable because we can have a lot of requests at the same time, as we don't have to process anything, we won't break our server. And following these ideas or these benefits that the static web pages offer, they came up with this concept called the Jamstack. The Jamstack is a new way of building websites and applications that deliver better performance, higher security, lower cost of scaling, and better developer experience. This is the formal definition, but if we analyze the name, the J comes from JavaScript, the A from APIs, and the M from markup. And the Jamstack side or the Jamstack philosophy follows some principles. We need to generate cacheable static assets at build time whenever is possible. So we will have a project or a solution or a website that when we build this project, we need to generate static assets like JavaScript files, CSS files, or HTML files whenever is possible. We should deploy these assets to CDNs. CDN, it's a content delivery network. It's a group of servers that are interconnected between them, and they are installed in different geographic points of the world, and they are optimized to deliver static content better and more performant and in a cheaper way. So, for instance, if I request a static asset to a CDN and I live in Argentina, instead of, I don't know, if I'm visiting a site that has their servers in Australia, my request will travel to Australia to get the content. But if I'm requesting the same content or a static asset to the CDN, the content will be delivered from the closest node. These servers are called node. The closest node that I have, let's say, I don't know, Brazil, for instance. So what the CDNs do is that they replicate the content and the static assets in all the nodes of the network to be available in all the points in the geographical places in the world. And the last principle is that we should use client-side JavaScript to call third-party APIs and serverless functions if we need dynamic interactions or data. So this graphic displays basically the idea of the JavaScript approach, the Jamstack approach. We will have a build system that we can execute with a continuous integration or continuous deliver system. And we will execute our project and generate static assets whenever we build our project and deliver them to the CDN. So we will have high performance static frontend, HTML files, JavaScript files, or images. And if we need dynamic content or data, the JavaScript code will call APIs, third-party APIs, or APIs that we created ourselves, or maybe serverless applications that we created to generate this dynamic content. One concept that is interesting is that as we are generating static assets whenever we build our application or our project, we need to have these atomic builds. What it means is that whenever we build our application, we will do that for the complete site. We will generate all the static assets that we need to make our complete website work. We can't have partial builds because maybe we will have a part of one build and a part of another build in the same instance of our website, and that will make our web page not to work properly. So we need these atomic builds. Or we build the complete site, or we don't build the site at all. But to follow this approach and to create sites following the Jamstack approach, we have some tools available to make this a complete workflow. For instance, the static site generators. And a static site generator is a software that produces and deploys a static website using data sources and templates. So we will have databases or third-party APIs or serverless applications on one side, and on the other side, we will have static templates that we will mix them, execute code with the static site generator, and we will generate our website, which will be composed by static assets. And we should deliver these static assets to the CDNs, and that will make our sites to be available to be visited. There are a lot of static site generators. They depend on which programming language do you want to use for the templating and the processing. For instance, if you use JavaScript and you like the React framework, you can use Next.js or Gatsby. Or if you like the Go programming language, you can use Hugo. Another component of this workflow are the content management system. It is an application or a set of related programs that are used to create and manage digital content. So these sources, these data sources that we mentioned when generating the static assets, they can be databases or services, or we can store the information in a content management system. You may know some of them. For instance, WordPress, Joomla, or Drupal, they are content management system. They offer you a platform with a backend where you can create the content for your website, create the entities and the articles and the text that you will expose in your page. And on the other hand, they offer a front-end layer or a presentation layer where they expose the content that you created in the backend. But as we are using static assets and we want to use static pages for our website, the presentation layer that this platform offer to us, they don't work because, for instance, WordPress uses PHP to generate the pages, and they are server-side rendering languages. But what we want is to use static pages in the front end, but having the backend part of the content management system. And that's where the headless CMS are born. A headless CMS is a CMS where the content repository is separated or decoupled from the presentation layer. So we will have all the backend available for us to create content and to handle the entities and the data layer of our application, but we won't have any presentation layer at all. We can create the presentation layer that we want and use the data as we want. There are many headless CMSs that we can use, and they difference on how they store the information. We have some headless CMSs that store the information in a database and they expose the information using an API that we can call with our JavaScript code or the static site generator. There are other types of headless CMSs that store the information using Markdown, the Markdown language, and storing that in files that will live in the same repository where our application lives. This repository can be, for instance, control version repository like Git, GitHub, or GitLab, for instance. And that we have a lot of options that we can evaluate at the moment of creating our web page. And there's one service to build, deploy, and host our application. Well, not one service, but we could evaluate one service to do this. To build, integrate, deploy, and host our applications. There are some platforms that automate a lot of tasks that we were mentioning before when generating all the content of our website. So for instance, if we store the files that compose our website in a GitHub repository, These platforms, what they offer are triggering a build action whenever the content or the files of our application are changed, and triggering this build action, generating the static content, and after that, delivering this static content to CDNs where our applications will live and we can visit them. These are some examples. Vercel, GitHub Pages, or Netlify are platforms that offer all these services and all these tasks all together. They analyze or they watch our GitHub repository. If we make a change to files in a repository, they build the site, they generate the static content, they deliver the static content to the CDNs, and well, they maintain the CDNs for our website to live. But okay, this conference is about Azure, and what I wanted to do is to show you that we have many services that Azure offer to create website following the Jamstack approach. For instance, Azure Static Web Apps. It's a service that hosts our applications, but it also makes all the work of executing the builds, generating the static assets with the static site generators, and delivering the static assets to the CDNs that already they already are in Azure. This is done with GitHub Actions. So whenever you create a pull request or you commit some changes to your branch in your GitHub repository, a GitHub action will be executed and a new build will start to generate the static assets and to be deployed in Azure CDN. For the dynamic part of our application, we will have Azure Functions. We can create Azure Functions to be called by JavaScript and to, I don't know, execute operations or bring in data from the database, and we can return that dynamic content to our pages, and we can display that in static assets living in Azure CDNs. There's a good part that Azure Static Web Apps service already contains Azure Function. So if you save your Azure Functions files in the same repository as your website that will be generated by static assets, they all live together and they all can be analyzed and built and deployed by Azure Static Web Apps service. Another service that we can use is Azure Pipelines to for the continuous integration or continuous deliver of our web application if we want to add more behavior whenever we build our site. And if we want to add authentication or authorization to our web application, we can use Azure Active Directory with a lot of functionality exposed to, I don't know, login using Google accounts or Facebook account or our authentication server. And if we want to store data, we have Azure Cosmos DB or Microsoft Azure SQL Server Database, two different databases services that we have available inside Azure. And what is good is that they offer APIs that we can call to make operations related to the data. We don't have to create a complete database center and manage it. We just have to worry about the code that we create and that execute and that brings information from the databases. And we have another service that we can use to integrate to our website, which is Azure Search. If we want to add a search to our websites, we can use this service and not having to create all the logic behind the search that all the pages or the sites have. So these are services that we have available inside Azure platform that we can use to create sites following the Jamstack approach and using static pages, serverless computing, databases that we can use calling APIs instead of creating databases servers. And that makes super easy to create websites, and it is a richer developer experience when creating new websites following this approach. So we are reaching to the end of the presentation, but we will mention some pros that the Jamstack approach has. We will have better performance in our site. We will have cheaper servers because the CDNs will expose our web application, and the CDNs are cheaper than a server that has to execute a platform to generate dynamic content. We will have a better caching because caching a static asset is easier than caching a dynamic generated page. We will have more security because we will have less code to execute when a request comes to our website. They are easier to scale because we will generate new static assets, but that's all the complexity that we are adding to our website. We don't have any behavior change there. We will have better SEO, as we mentioned before, and we will have a better developer experience because even though that we are creating static assets, we are using new techniques and services and products, and we have really a lot of options and alternatives to evaluate when creating our websites. Headless CMSs, static site generators, or even the services that Azure offers us. They are super cool. They make super easy for us to create new web pages and to start with web pages and not having to reinvent the wheel, because that's an important point of the Jamstack. We shouldn't worry about parts of our application or modules of our application that are not fully related to the product that we want to build. If we have people that are experts in security or databases or hosting websites, like people working in Microsoft, for instance, we have experts in security, in caching, in maintaining servers, in databases. So why don't we leave to them to make what they know and to create products following all the knowledge that they have, and we worry about our website and our application and the functionality that we really want to add and to add value to it. But the Jamstack has some problems. For instance, as we are using different services and different third-party APIs, many of them, maybe they have costs that we have to evaluate, and we will need to make a decision and to choose the best alternative depending on how big is our website or will be. Many of them have free tiers, but we have to evaluate when that free tier starts to having a cost. So that's something that we have to evaluate. Maybe we will be overwhelmed by all the alternatives that we have to evaluate. On the other hand, as we will have many dependencies on third-party APIs or services, we will depend on how they give shape to their products and how we use those products. And we will have these dependencies when we create our websites. As I mentioned before, we have the atomic build to completely generate our site and deliver it. The thing is, when our site gets bigger and bigger, this atomic build time will grow, and maybe whenever we want to generate a new version of our website, we will have to wait a lot for it to be completed. There are some platforms and some services that are developing new partial builds to avoid this, but at the moment we have to wait for the complete site to be generated before we can deploy it. And that can take some time. And if our page gets bigger, more time. And on the other hand, even though that we mentioned the headless CMSs, maybe it's hard for the content editors to add content or to create content for our websites, because not all the CMSs have a friendly backend to be used, or maybe we have to create some modules or to make user-friendly the way of creating content for our web pages. So that's something that we have to evaluate. So the Jamstack is a good approach. It's a new way of creating web pages with better performance, with cheaper cost, easier to scale, more secure websites. And maybe it's not the only solution to all the problems in the world, but it's a good approach and a good idea that we can follow, we can evaluate at the moment of creating new web applications. And I don't know, maybe following this approach, your next product gets bigger or gets easier or gets more performant, and it's something to keep in mind at the moment of creating new web applications. So thank you very much. Enjoy the rest of the conference and see you soon. Bye-bye.